Hello my dear students. Now we'll discuss about the square numbers. Okay. So first the square numbers is the number. If any number you can write as a product of two same numbers. We know that see few numbers are there, so we'll take it 25. 25 can be written as 5 into 5, product of two same numbers. 196. It can be written as 14 into 14, product of two same numbers. But you see 120. 120 can be written as a product of two numbers but not same numbers. 120 cannot write as a product of two same numbers exactly. So this number, this 25 and this 196, we call it as perfect square numbers, but this 120 is not a square number. Okay, this is not a square number. This any number, if you are able to write as a product of two same numbers, then we will call them as a perfect square numbers. Okay, so we'll discuss about the square numbers and its properties, some properties about them. Okay, first we'll see the square numbers here first. Okay, first we'll write the square numbers from 1 to 20 first. 1 square is a 1, 2 square is a 4, 3 square is 9, 4 square 16, 4 fours are 5 square, 5 fives are 25, 6 square 36, 7 square 49, 8 square 64, 9 square is 81, 10 square is 100, even 11 square is 121, 12 square 144, 12 twelves are 13 square, the answer is 169, 14 square, the answer is 196, and 15 square, the answer is 225, 16 square 256, 17 square is 289, 18 square is 324, 19 square, the answer is 361, 20 square, the answer is 400. I written here the numbers from 1 square to 20 square. Here you see these numbers 1, 4, 9, 16, 25, 36. These all numbers we are calling as a perfect square numbers. In these numbers you see, will any number you want to find the square, you don't have any other rule there, just you want to make a square of any number, multiply the number itself. 72 square you want it, so 72 square you can multiply 72 into 72, so you get the answer. That's all. So square number, the answer which is getting, that is called as a perfect square number, but that is the answer for 72 square answer is that. Okay, now here you can see, now once some properties we will observe now. A few properties here about the square numbers. First you observe the square numbers. Ones places you observe. What are the ones place? Ones digit. What are there? 1, 4, 9, 6, 5, 1, 4, 9, 6, 5, again 6, 9, 4, 1 and 0. So it means these are the digits. If you write in the order 0, 1, 4, 5, 6, 9. This is the order it is, if you are writing in the order. Now these are the ones digits of these square numbers. See, when you see the digits here, some digits are actually missing, that the digits 2, 3, 7, 8. These digits we never get in the ones place in this. Observe, your 6, 5, anywhere we didn't get it in the ones place at all. So here we have a one rule. We can say that 2, 3, 7, 8. If it gets in the ones place, definitely that number is not a perfect square. Suppose if I give you 1, 1, 2, the ones place is 2. So definitely this number is 100% it is not a perfect square. Any kind of number, 7868, the ones place is 8. So this is not a perfect square. And 8225, this number is a perfect square or not means here the ones place got it as a 5. If the ones place got it as a 5, here we have in this list, but this is we cannot compulsory, we cannot say surely that it is a perfect square. This may happen, maybe perfect square it is. So the rule you see here, the first rule here in these digits, if the ones place is 0, 1, 4, 5, 6, 9, any of the digit is getting in the ones place of a number, that is maybe a perfect square. But if the ones place is 2, 3, 7, 8 is there in the ones place, then that number is surely not a perfect square. Compulsory, we cannot write that kind of number as a product of two same numbers. That's why it is not a perfect square. It is. This is a first rule. You can understand. The first digit, ones digit, if this is there, it's not a perfect square. And if this is coming any one of the digit, it is maybe a perfect square, but not sure. If you want to say surely it is a perfect square or not, then you have to do for the process that there are other processes there, prime factorization method and other methods. You should go for the method and you have to confirm that. Now we'll go for one more property, that here odd numbers. See, now we'll take sum of the odd numbers. So we'll take 1 plus 3, answer is 4. Here you observe 1 plus 3 got it as a 4, and 1 plus 3 plus 5 you got it as a 9, and 1 plus 3 plus 5 plus 7, you observe this, it's got it as a 16. Are you observing here? When you are adding the continuously two numbers, two especially odd numbers, if you add them, you are compulsory getting a perfect square number. If without missing any odd number, if you are adding the odd numbers from 1 to next till the day, till any number you are adding, that all together compulsory makes a perfect square number here. 1 plus 3 is a 4. But you can observe here, you are adding the two odd numbers, so you got the answer as 2 square. Here you are adding the 3 odd numbers, so your answer is 3 square. Here 4 odd numbers you are added, 4 square will be your answer. If suppose 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. If I ask you what is the sum of these digits, a very simple answer, you count the number of odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers are there, so your answer will be 11 square, that is equal to 121. So this answer will be 121 is the answer it is. So you can add and check also it is. Anytime the continuous odd numbers from 1 gives always a perfect square. This is our second property here. Now we'll go for the third property. We'll see the third property here now. The third property you observe now. 9 and 4. These both are perfect square numbers. 4 and 9. In between them, how many square numbers are there? 4 and 9. Is it exactly compulsory? They are perfect square numbers. But in between them, there are some numbers which are not perfect squares. But how many are there? You can count here 5, 6, 7, 8. These are the numbers which are not perfect squares it is. Okay, but you see that 2 is a square of the number, 3 is a square of 3, 4 is a square of 2. Okay, so 2 square and 3 square between you have a 4 numbers are there in between the 2 square and 3 square. Okay, if I ask you now the numbers from 5 square and 6 square, 5 square and 6 square, in between them how many numbers are there? In between them means it's a 5 square is 25 and 36, 25 and 36. You observe 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That's all. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have it 10 numbers in between them. It is not counted. 25 and 36 both are not counting in this list. So without counting the both, in between them there are 10 numbers. But without doing this entire process here, 5 square, 6 square, you can, without writing the numbers, you can give the answer. Once you observe this and how many numbers are there in between them. You observe here, the smallest square number is 5 here. 5, here you have it 10 numbers in between them. Here 2 square and 3 square. Here 2 is the number, 2 is the smaller one, and 2 square and 3 square between you have a 4 numbers. It means double of 2 is a 4. Here double of 5 is a 10. Suppose if I ask you 16 square and 17 square, in between them how many numbers are there? Here the 16 is the smaller number, so double of 16, 2 into 16 will be 32 numbers are there. Okay, so 16 square and 17 square between, squares of 16 and 17 between, you have a 32 numbers which are not perfect squares. Compulsory they are not a perfect squares here. If I ask you 27 square and 28 square, in between them how many are there? The same 27. 27 into 2. The answer is 54. 54 numbers are there which are not perfect squares at all. So this one we are writing as a general form that in between the n and n square, in between the squares of n and n plus 1. Okay, squares of n and n plus 1. In between the squares of n and n plus 1, there are 2n numbers will be there. There are 2n numbers exist here. In between the squares of n and n plus 1. Generally with the normal numbers n and n plus 1 between, there is no numbers. But the squares between, there are so many numbers. So what are that? It's a 2n numbers are there. What are the? You can write after writing answer only, but how many are there, you can give a direct answer here. Okay, this is the one more property. So we have done the 3 properties here, and we have it triangular numbers. Okay, so triangular numbers, what are the triangular numbers? Do you know what are triangular numbers? 1 is a triangular number, and 3 is a triangular number, and 1, 2, 3, 4, 5, 6. You see this is a one triangular number, 6. 1, 3, 6. Okay, like this continuously so many numbers you get it. So these all numbers you see that. Any 2 consecutive triangular numbers if you add, it will form a square number. 1 and 3, 1 plus 3, answer is 4. 3 plus 6, answer is 9, which is the square of 3, square of 2. Okay, two triangular numbers, two consecutive triangular numbers, if you add, it makes a perfect square number. Okay, this is that. Next, phrased as sum of two consecutive numbers. Suppose you take 25. 25 can be written as 12 plus 13. This is the way we can write it. And 49. 49 is the square of odd number 7. Okay. 5 square is 25. 7 square is a 49, which can be written as 24 plus 25. That's all. So every square number, n square you can see, n square when you want to represent, you can write as a product of n square minus 1 by 2 and n square plus 1 by 2. You can write in this order. So two natural numbers you can write. Okay, so in this way you can take any number. Suppose if you want to write here, this is an odd number 289. So 17 square you want to write it as a two consecutive numbers total. So then how can you write? First you do that n square minus 1 by 2. 289 minus 1 by 2. The answer will be 288 by 2, which is equal to 144. And the next n square plus 1 by 2. It means 289 plus 1 by 2. It is a 290 by 2 it is. 2 ones are 2, 2 fours are 8, 2 fives are 10. It means 145. So you can write that 289 as a sum of 144 and 145. Two numbers total it can be written. That too, any square odd natural number only, not the even natural number. Okay, odd natural number can be written as a sum of two natural numbers, sum of two continuous natural numbers here. And other properties also is that the properties is that you observe in this list first. In this list of numbers you see, one is a even or odd number. One is a odd number and its square answer is also odd. 2 is a even number and its square is even. 3 is a odd number, its square is odd. 2 is a odd number, 3 is a odd number and its square is also odd number. Here you see that square of any even number, you take anything in this list. 6 even, 8 even, 10 even. Square of even number is always even. Square of odd number is always odd, compulsory. 5 square, 15 square, 13 square, you see it is an odd number. And square of negative number, always positive. Always positive. You can see that. Here minus 5 whole square is there. It meaning is that minus 5 into minus 5, which gives that minus into minus plus, and 5 5 is a 25. This is the square of that. So you got positive. Okay. So here square of any number, any even number is even. Square of odd number is always odd, and square of negative number is always positive. This is that. So these are the properties and these are the square numbers. So in this finding, one small multiplication, small finding square number, I will show you here, square. So you see that, suppose square of 15. 15 square is, you know that it's a 225. 25 square, do you know? 25 square means it's most probably knows that it's a 625. But you observe here the ones place is 5 now. So if the ones place is 5, we no need to do the multiplication of 25 and 25. We no need to do multiplication. We can just directly can write the answer. Suppose you see 75 square answer. You want to write the 75 square. First, leave the 5 ones digit and tens digit 7 you take. 7 next number? 8. So 7 8s are 7 multiply with 8. Next number, so answer will be 56. And the 5 square answer is 25. So this is your answer. 75 square answer is 5625. Suppose you are writing a 45 square. 4 next number 5. 4 5s are 20. And it is 4 5s are 20. And the next 5 square is 25. So 20 25. This is your answer, 45 square. But this is only possible when the ones place digit is 5. You can do the you can write the direct answer for this square number. These are the square numbers, and it is compulsory need to remember 1 to 30 square numbers. If you remember, it is easy for doing some calculations. And these are the properties. So